Right, the last thing that we're going to look at in Chapter 4 is we're going to look at something called the coefficient of determination. Right, so we see the word coefficient. Notice that it's not the first time we've used it in this chapter. Right? We talked about our correlation coefficient before. This coefficient of determination is directly related to our correlation coefficient. Notice that it is being given to us by r squared. Right? So we're literally taking our r value that we had from before, our correlation coefficient, and we're squaring it. We're multiplying it by itself. This is going to give us the proportion of total variation in the response variable that is explained by the explanatory variable x. Right? So the coefficient of determination is going to be between 0 and 1, because when we square negative numbers, we get positive numbers. So we're going to write 0 is less than or equal to r, which is less than or equal to 1. The coefficient of determination is usually converted to a percentage. So that means that percentage is going to be between 0% and 100%, right? If we are between 0 and 1. Right? If r squared is equal to 0, then the line has no explanatory value. If r squared is equal to 1, the line explains 100% of the variation in the response variable. If the association is linear, the larger the coefficient of determination, the larger the r squared value is, the smaller the variation or scatter about the regression line, and the more accurate the predictions tend to be. So what our coefficient of determination gives us, it gives us a way to decide whether or not our predictions are going to be accurate, and give us a better idea of the amount of variation or scatter, and as much of the variation in y that can be explained by our variable x.